Before I cover the next module, which is the sample and hold and noise module here, I thought it would be very helpful to go over normalization and what that term means in a modular or semi-modular synthesizer, and why you need to know about it to understand what's going on sometimes is because some of the patching is pre-done for you in some modules. So there are kind of standard paths and basic patches that you're going to be using so often that the designer of the module has actually made some of those connections for you ahead of time that you can break with patching. But when you fire up your system, some of these jacks are actually all connected to each other already without having to patch them together. So this is a Eurorack jack. This is what most Eurorack companies use or something similar. And a Eurorack patch cable has a shield and a signal. So it only really needs 2 pins, but this has 3 pins. And if you look inside here, you'll see how there's kind of a sprung leaf that when nothing is plugged in is touching this, which means that this pin is attached to this pin, and then this outside one is attached to the shield. So when you plug in a cable, the tip pushes that spring apart and disconnects these 2 pins, and the signal here is now attached to this pin. So what this allows is when nothing is plugged in, the designer of the module can attach the default signal that they want to come through this jack to this pin, and it will come through normalized through this jack, and that will allow you to set up a kind of a default configuration that can then be broken by your patching. This is the EDU sample and hold and noise module, and it's actually 3 circuit blocks all behind the same panel, pre-configured in a default patch that is the way that you would often be using these circuits together, but you can also use the circuit blocks separately for more advanced patches. The first block is the noise section. You've got pink and white and blue noise. Pink sounds like this. White noise is a little bit hissier sounding. And then blue noise is hissier again. Sounds like it's got a lot more high frequency content going on as you go up. You start kind of low, and then you get hissier and hissier as you go up. Noise sources are helpful for building percussion instruments. Noise is an element of snare drums and shakers and stuff like that, but they are also really useful as a source of randomness, which is the point of the next circuit block here, which is the sample and hold module. A sample and hold module is a really classic module that samples a random voltage every time the clock fires. The random voltage source is the white noise. So the white noise is plugged in, is normalized to the CV input here. The clock is on board, and the speed of the clock is controlled by this big knob here. And every time the clock fires, it takes a snapshot of that random voltage and holds it and outputs it here at the sample and hold output. So we'll set up the classic kind of robot speaking voice, and that is a self-oscillating filter. And the sample and hold output, we are going to plug that into the CV control of the filter. And as we turn up the speed of the clock, we'll get faster random voltages, and if we slow it down, they'll come slower. And the range of how far apart those random voltages can be is controlled by the CV level potentiometer here, which is an attenuator for whatever's going into the CV input. So right now it's the white noise normalized to that CV input, and we can change how large the random voltages can be away from each other. But there's something missing from this patch. The classic robot voice has got some sliding in between the notes, and we don't have any sliding here. It's just jumping from one to the other. So sliding in between notes is the last circuit block, and that is what a slew does. So a slew circuit takes voltages and slides in between them at a rate determined by your slew potentiometer, which is this other small potentiometer right here. And on this module, that's your other normalization. So the output of your sample and hold, which is your stepped random voltages in this patch, is normalized to your slew input, and then they are slid in between and come out your slew output here. So let's listen to this patch again, and let's increase our slew. And that sounds a little bit more familiar. And just showing the effect that the slew has on a voltage sequence like I have going here. The original sequence is in the yellow trace or the green jack here, and the slewed sequence is the blue trace, and it's what's controlling the VCO. So as I turn the slew up, you start getting some slides in between notes. And it's essentially a filter that works on very low frequency content. So instead of the VCF, which is a filter for audio, the slew is like a filter for your control voltages to slow down fast transitions and give slides in between stepped values. So all of these circuits are usable separately. We can just use the noise sources if we're designing a percussion or something like that, but we do not have to use the sample and hold to sample randomness and just use it to make random voltage changes. You can use it to save notes that you're using for pitch. You can use it to manipulate melodies and manipulate arpeggios and stuff. So the patch I've set up is the CV output of the sequencer is what's being sampled by the sample and hold. The clock is being driven externally, so the gate output of the sequencer is what's telling the sample and hold to sample that melody voltage every time a new step fires. I've got all the gate switches on right now, and the result is then internally normalized to the slew circuit, so that slewed voltage is going to be controlling my oscillator, and the sequencer is also firing an envelope. So if I turn the effect of the envelope up a little bit, you can start hearing something happening. And what this does is gives me a way to tie and skip steps of my sequence. Because if I shut off one of the gates, the sample and hold will skip that note, and I can take it out and put it back in. So if I flip this gate off, it's just going to repeat the note from step 1 and skip the note that's programmed at step 2. And if I flip this back on, there it's back. I can add some slew. And I can move around. I can save my melody, but keep recombining different combinations of the notes that I have saved on my pots here.